Good afternoon, everybody. Welcome to this webinar from Advenica. We are sending from the Advenica headquarters here in Malmö, southern Sweden. And my name is Michael Holmgren. I'm the team leader for sales. And with me I have...
My name is Tove Bergdahl, and I'm product manager here at Advenica and responsible for our data diodes.
And we will start immediately because we have limited time, so we will go directly into the presentation where we will introduce the new version of our data diode DD500 with the additional R. And Tove is a product manager for this product. So let's go directly into the content.
Yeah. Let me just switch the slide, hopefully. There we go.
All right, thank you. So to start with, what is the problem or the dilemma? Well, everything in our modern society is creating data. And if data is created, the purpose of that data is that it's supposed to be used for something. And if the data is created in domains that are of very high importance, needs to be very secured for different reasons. But we still need to get data out for monitoring, for predictive maintenance, for remote services, and for improved operations. But at the same time, we need to ensure the network integrity and availability because it can have safety risks if it's not operating the way it should be. So we need to keep the domain isolated with the critical systems. And we also need to be up to compliance regulations. So what we need to do is we need to get data out versus handle risk of anything coming in. And this is the sweet spot in general for our data diodes. Next.
Yeah, so we want to show today in the webinar how we can actually enable that in practice.
Yeah.
Yeah.
Exactly. So a bit of history and background. So how we bring high assurance to the transport sector. Well, the idea of data diodes, it's not a new concept. It was actually invented all the way back into the 1970s, starting in the nuclear industry to protect the environment or production environment for the nuclear power plants. Then after that, from the 90s, defense and governments discovered the usability of data diodes. And this is where Advenica entered the market as well with our data diodes, delivering to defense organizations and authorities. Then in 2010 and forward, we received a lot of interest from critical infrastructure organizations, utility companies and alike, and other OT running organizations that wanted to protect their operation technology, but at the same time, they wanted to use the data created in those security domains on the IT side or maybe even in the cloud. And then finally, now we have received a lot of interest and seen a lot of requirements from the transport sector and especially from the railway industry due to the big change in the industry and also that the digitalization of the railway industry or sector.
Yeah, so what we want to show here is that we're not about to introduce something completely new for the rail and transport sectors. It's bringing in something that is proven already since the 1970s, actually, to protect very high security environments, and just bringing in this technology into future now rail and transport.
A proven technology.
Yes, a proven technology. But before we move on, we believe that it's important for you, the audience, to understand what the data diode actually is. And this may be old news to some of you, but actually we often get a lot of questions about this. How does the data diode actually work, and how is it different from a firewall or a gateway? So, well, in a traditional network, there is always bidirectional communication. So firewalls are used to block traffic in a very efficient way, and used as a segmentation product in many cases to control communication. And this is usually fine, but when you really have a safety critical system, then a firewall may not be enough. Because firewalls do rely on configuration, and it does rely on software. And so even it may be unintentional, there is a risk of misconfiguration or having vulnerabilities in this type of equipment.
And actually, it's for all type of network equipments like routers and switches and so forth that are software configurable.
Yeah. So a data diode works differently. So it enforces the one way at the hardware level. So it has a physical one-way link, and there is no software that can control this data direction. Meaning then, in this simple image, that in the OT case, where you often want data out from your OT environment, you can do this safely and securely, and still keep an air gap in the reverse direction.
Exactly. But we do also use software sometimes.
We do, and the data diode is, since it's one way, it could be difficult to integrate in traditional networks, since a lot of systems and solutions and applications require bidirectional communication. And their software is often used in combination with data diodes, sometimes called unidirectional gateways or similar names for them. But and then it's used to convert bidirectional communication protocols to unidirectional, so that they can
work over
the data diode, exactly.
So the purpose of the software is to help data traverse the physical data diode.
Yeah, exactly. So actually digging a little bit more deep into what's happening inside the data diode. Well, this is a very simple illustration. Of course, it's a lot more complex inside the product, and this is zooming into the actual diode function. But just to understand how it works, and how we can claim that it is guaranteed one way.
Physically only one way.
Physically only one way, yes. So we have data coming in in the OT case, often from the safety critical domain, and we want data out on the other side. And inside the diode, there is a transmitter component and a receiver component. And the only thing connecting them is this optical link. So light travels from one way from the transmitter to the receiver, and this is how data is communicated from the data into the data outside. And quite a common explanation is using this flashlight. So imagine a transmitter has a flashlight, and it sends light pulses to the receiver, and the receiver only has an eye. So the receiver does not have a flashlight and cannot communicate back. Even if it could, the transmitter is, so to say, blind. It doesn't have an eye, so it would never be able to pick up on the light pulses. So this is how we ensure that it's really physically one way.
Yep.
Okay.
Yeah, and so data diodes, we see more and more use cases, but we also understand that not one data diode can handle all different use cases. So traditionally, the data diode was built for data centers to be put into a controlled environment with 19-inch devices. The environment was controlled with heat and
air conditioned
and so forth, and throughput was of importance. But then the requirements changed a bit because customers wanted to use the data diodes out, especially in the OT world, close to the machines and close to the factory floor. And then it was installed in cabinets like the one in the picture here in the middle, with more limited space, DIN rail mountable systems. They wanted to have it low maintenance and simple installations, because installations could be done by electricians or cable installers or something. So that was the ambition. And now we see more and more requirements of the data diodes being installed even further out in the network, close to, for example, trackside installations, where we have additional difficulties with harsh conditions like temperature, vibration, and also requirements of specific sector certifications.
Yeah, so then going from the more rack-mounted models, we now see a need for data diodes with the same guaranteed hardware one-way flow, but in different form factors and with different certifications.
Yeah. So if we look into more or less any segmentation model, this might be Purdue inspired, as railway is the main topic today. We took that as an example. So you can find borders or domain separation or layer separation points where data diode can bring a lot of value, guaranteeing that data can only flow from lower levels to higher levels. And this is can be one or multiple points they are installed. But also, if you click yes, by using data diodes, we can create shortcuts. So actually sending data directly from a very low level equipment directly to the IT side, or maybe directly to a cloud environment. It might be from authorities that wants to have data directly from your trackside equipment, for example. But it might be something else where you want to send data to a cloud environment, or actually only to the IT side. And without having to jump all the layers, you can actually send the data directly from a low level products. And here we also see that we can use different data diodes. So maybe in the higher levels layers we have the traditional ones, 19-inch devices. But if we want to connect directly to the low level equipment, we probably would like to have DIN or OT designed data diodes.
Because here we are closer to the equipment, and we need to be next to them on the track. Okay, so now getting into the actual product that we have just released. the model is called DD500E-R, as we said before, and this is a new model and purpose-built for this installation in cabinets next to railway tracks. And as we mentioned before, the hardware, the guaranteed one-way data flow is supported by a hardware-based optical separation, and it's also like this in this product. And to meet these installation requirements in small cabinets, it has a very compact small form factor. It's actually here with us on the table. It's in the palm of your hand, and this is actually a really small form factor for a data diode with IP connectivity capabilities. So it has some minimal software inside. Normally, small form factor diodes like this are pure hardware diodes. They can also be really good. We also have some models like that, but they can be a bit more challenging to install in an existing network. Since the pure hardware can only communicate on the layer 2, so you need to address them with a MAC address. But this does have as minimal software as possible, since we don't want to open up for attack vectors, or as few attack vectors as possible, I should say.
But also keeping the maintenance.
Keeping the maintenance to a minimum,
yeah.
Which comes to my last bullet there. Thanks. So a lot of focus has been put on low-touch installation, so it should be easy to deploy, easy to configure. As few parameters as possible, but still enough, so you have what you need to make it fit into your network equipment.
So for a bigger project where multiple installations are to be made, you can have a standard configuration and have someone quickly trained to install them and so forth in the field.
Yeah, exactly. So the configurations are file-based, simple text files, easy to follow, and you could easily have a copy of them and just change a few of the variables or parameters that you would need for a specific diode. So some key features, there's of course a whole spec, and you can download that from our website.
Advenica.com.
Advenica.com, yes. So just to mention a few 100 megabit interfaces, I can mention that throughput for UDP traffic is around 40 megabit. Actual throughput is, of course, the interfaces. The product supports redundant power, even though during normal operation you should power the both sides of the diode. But in case you have a power failure, the device can operate just by powering one side. Normal DC, 24 volts, or actually power over Ethernet is also supported, in case you have that option. Yes, the railway trackside certifications for EMC and environmental conditions, and we want to mention especially the operational temperatures from -40 to +70 degrees.
So it's certified for that.
Certified for that, yes. It's part of the trackside environmental conditions. But there is also, of course, vibration and shock and so on, similar. Yes, the software and configuration, as I mentioned before, simple application for the configuration, and we have also a hardware root of trust, so that we are sure that it's only our software that is signed by us, Advenica, that runs on the product. Right now supports UDP. MQTT is around the corner. It's just a few weeks away. We will launch support for that protocol, and more to come after that.
Yes. It's not end of the story.
Not the end of the story. No, it's only the beginning.
Yeah.
Okay, so finally we want to mention a few key application areas. So starting with what is probably the most immediate and relatable situation, so existing systems. So today, operators want better visibility, want to understand what's happening in the field, detect issues earlier, and reduce need for manual inspections. So for this, we need to access data from the trackside equipment or from signaling or control systems. But infrastructure is usually quite old. There is a lot of brownfield installations, and these were never designed to be connected. So reliable and safe, but they cannot easily provide access to the data that we need. So, and because they are safety critical, we cannot just open up that connection. So it's a lot of manual processes and limited visibility. And then, of course, the key question, how to get data out without touching this system. And this is exactly where we see a good place for this product. Perfect bridge, as it says, between old and new, and enabling access to the data without touching the safety critical logic that's already in place.
Yeah. We're a bit limited on time, so keep up the pace.
Yes, keep up the pace.
Yeah, like a train running through.
Yeah. New projects. So looking at new signaling projects and the larger, broader digitalization journey in rail. So across Europe and across globally, we see a lot of investments in the modern systems, such as ETCS and digital traffic management. And they are, of course, much more capable than legacy, and they are designed with the data in mind. So there is a clear expectation that data will be available. But the systems are, of course, already still safety critical, highly regulated, and you cannot just start connecting everything. So again, how do we enable this data access? So we think design it in from the beginning. So clear separation and controlled data flow. And here is where you can add data diode as a standard secure interface. So instead of solving it project by project, you can define one secure interface that's part of the design from the beginning. So adding it in directly in the new projects and not later. So it's there from the beginning. And our final application area here, cybersecurity compliance, of course, it's a hot topic in many sectors now. And again, as we said a few times now, as the rail system has become more and more connected, cybersecurity is, of course, a major focus area here as well. And becoming increasingly, safety is well recognized, of course, in this area. But now I think there's not a large difference between safety and security anymore. They actually are tightly connected. So a safe system is also a cyber secure system. And we see many regulations here. NIS 2, of course, more on the organizational level, and IEC 62443, which has all the organizational system and even down to the component compliance. And the TS 5701 for railway specific cybersecurity standard built on 62443. So across all these, there is a strong push for network segmentation to secure your zones, know your data flows between zones, control them. And for this, the simplest way to prove that you have actually done your homework here is to have a data diode where you really want the one-way data flow. Yes. Reaching the end. So summarize.
Summarize.
Yes.
Exactly. So again, we are introducing the DD500ER model, and it is to collect and export operational data from trackside systems to enable monitoring, integration, and new digital services. To preservation of safety critical systems, so be able to get data from safety critical systems without exposing them to any risks. Enable digitalization without compromise of safety, easier certification and audits. And as Tove has talked about, one of the benefits is that whenever there is an audit, it's very easy to explain that the data diode is one direction and the policy and so forth, it's nothing you can influence. It is what it is. And bringing strong compliance according to IEC 62443 and other security principles. So that was the today's agenda from us that we prepared, and now to the scary part, Q&A. So we do have some questions here. First question is, how has the feedback been from customers?
Yeah.
You or me?
Yeah. Well, I can start, and we can mention that we have developed this together with a couple of customers. So we had them with us, let's say like that, already from the beginning. So feedback has been very good. Customers especially like that the form factor and that it's a hardware diode. There are also software diodes we should mention, and they can often be kept smaller, but this they like that it's a combination of the physical separation in a small form factor. And the IP capability is also something that we got positive feedback.
And I would say that we have positive feedback both from facility owners or infrastructure owners, as well as OEMs that are interested in using the product in their delivery. Yeah,
true. So this applies both to like operators or asset owners, but also machine, as you said, machine builders and those who deliver equipment to trackside systems.
So next question is there a version of the data diode with M12 connections available? Now, as soon as she has launched the product, we always ask for something new.
Yeah,
so this is.
It's always like this.
Yeah,
but it's great. Of course, we want feedback and more requests. No, we don't have another version right now, I should say. But it's an interesting question, and if there are more, let's say, requirements or asks for this, then we may absolutely consider it. But right now it's Ethernet.
Traditional
RE45.
Yeah. So, but again, and this is in general, just give us feedback and requests, and we are very appreciated.
Yeah.
So now we have a very good question, and I don't know if it requires an answer, but there is no trains going when there's facing minus 40 degrees Celsius, but it's good to have the margin.
Yeah, it's good.
So
you never know what happens.
Appreciate that.
Good question, the other one. What are the two connectors? And maybe we should jump back to the slide, or you can actually see them from here. These are for configuration. So we separate the data input-output from the admin interfaces. Let's say this is also quite common in the bigger rack models that you do it like that. And we have special cables that come with the product, serial to USB, and you connect them to your laptop and run a small console-based program. Press the to configure it. Press the small button there you see over in and out. To set it in config mode, and then you upload a configuration, or you can also get some logs and you can get some device info and so on. So there's a small, let's say, admin app.
So we keep the configuration and management separated from the data flow.
Yeah, and then we have power. I don't know if you can see it from here, but power in here on the. Yeah. So yeah.
Yes. Quick last question: can the data diode be used for other areas than railway? Yes, it can.
Yeah, absolutely. Yes. That's it. We don't have time for a long explanation. Yes, absolutely, it can.
So thank you everybody for joining. We hope it was of value.
Yeah.
And we appreciate any feedback. You can contact Tove directly, or me directly, or anyone else at Advenica, and we will be happy to support you any way we can.
Yeah.
Thank you very much.
Thank you very much.
Have a good day.
Have a nice day.